Go.
So, good morning to everybody and welcome to this first Sisgeo webinar. The title is In-Place Inclinometers, different solution for various geotechnical applications. My name is Giovanni Caloni and I'm the Customer Care Manager of Sisgeo. And today's speaker will be Julien Prouvot, that is a geotechnical engineer and geologist with large experience in our applications and also in teaching and trainings. So now I give the floor to Julien to start the webinar. Thank you and enjoy.
Thank you, Giovanni. So welcome to everyone. I'm very proud to start this webinar, this first ever webinar from Sisgeo. So today's topic is one of our best seller. So it's about inclinometer, in-place inclinometer. So I'm gonna present again the company Sisgeo if you don't know us. Start also some definitions in order to have the same vocabulary afterwards. And then we will speak about our systems in themselves, their applications, and we will end with a Q&A session. As you can see in your screen, go to webinar or from the web, you have an icon to ask your question. So you can write down your question and we will take time at the end to reply to your question. So let's start over. So about Sisgeo. So as you know or don't know, we are a manufacturer. So we are designer and manufacturer for geotechnical and structural monitoring instruments. We are based in Italy, in Milan, and we are acting all over the world. I used to say that we are more than a supplier, so we don't just supply and produce things, we also advise, and we also advise over the simple instrumentation. We can advise also on the full geotechnique because we have a large experience among the group. So the main sectors that where we are acting are the dams, the tunnels, mines, railway sector, and all civil engineering structure in general. About the group itself, you have here the full group, so the main headquarters in Italy, and two agencies, commercial agencies in France, subsidiaries in France and Germany. Germany has been opened recently. And we have also two offices in Latin America and Asia, Thailand. A new brand office in Canada has been opened. And we have also a service company called Field, based in Italy, and two companies that are among the group with special products. Let's say Hugenberger is existing from more than a century and is producing devices for concrete dams instrumentation, so very specialized. Signum is much more a new player, newcomer, and producing in France some devices, a device to monitor the response of structure. It's a structural health monitoring device. So that was about Sisgeo. Now, let's talk about inclinometry. So what is an inclinometer? So in essence, it comes from the ancient Greek, etymologically. So divided into klinein, to lean, metro, to measure. So it's a measuring instrument for quantifying the deviation of a line. So the line is taken from the gravity, so the vertical line. So the application in borehole is to use the cumulative unit deformation. So we are measuring deformation at several steps, and we therefore determine a profile with respect to a stable reference, and the stable reference is often taken at the bottom of the line, deep in the ground. So what is the purpose of an inclinometer? So the general application that we can encounter in the construction world are the ground movement detection, also to measure the deformation trends, to perform deviation control, to determine and to analyze the amplitude and the location of the deformation. So when you don't know how it's moving, then this device can help you to understand how it's moving. And last but not least, the stability of a measurement line. So it's a different way to approach the application of an inclinometer. So you are assuming that your structure doesn't have to move, and your inclinometer will ensure with the measurement that your structure is stable. So you are practically measuring no displacement. So this different application, let's say it's this, more or less the same, but we don't focus on the same results and the same properties of the inclinometers. So how to express the tilt? So the trivial unit that we are using is commonly the angle. So the angle is is expressed in radian or in degree according to the vertical vector, the g. In topography, we can use the slope, so meter per meter, millimeter per meter, percentage per thousands. So commonly in Sisgeo, we express in sine of angle. So this sine of angle is analog to the slope, so meter per meter or millimeter per meter. It's valid for very low angles. So if you have wide angles like 30 degrees or more, it's not really valid because you have a difference between this length hypotenuse and the base length. So if you have a small angle, it's generally the case in our application. So the differential, you are measuring differential. So if this length is small, then you can express in sinus. So to get this displacement, lateral displacement, then you just multiply the sine with the base length of your probe. For example, 0.5 meter or 1 meter or 2 meter, etc. And then you get directly millimeters. So the inclinometer principle, they are based on the ISO norm 18674-3. So this is made with special casing. So the casing is a tubing. So this special casing is defining a measuring line. This measuring line, so the casing, is grouted, so linked to the soil that you have to, or the soil or the structure that you have to monitor. Then the ground movement or the structure movement will deform the casing. So this inclinometer system that you are using, manual or automatic, permanent, monitors the inclination changes of this casing deformed by the ground and subsequent transversal deformation. So the idea is that, so to use casing, this casing deforms, and then you get the deformation in profile with an inclinometer system. So I remind the principle of the manual device. So the manual device contains two accelerometers, so inclinometer sensors, and then you measure with it two axes, A and B, orthogonal axes. The measurements are performed at each step of 0.5 meters. So you measure each 0.5 meters. So you pull the cable and you stop the cable each 0.5 meter, and you monitor, you register, you note, write down the inclination values A and B at each position. Then you turn around the probe when you are finished, and you pull out the probe from the borehole. You turn around and you go back from the bottom and you perform the same measurements at the very same depth in order to have the opposite value. Then you make the average of the both values, and then it gives you the inclination. So the unit inclinations are summed from a fixed point. So you consider that your bottom point, for example, is 0, doesn't move. So it has to be real. So if you choose this point as a reference, the reality should be exactly this. This zone will not move. And then you sum your local inclinations step by step in order to get a profile. Then you perform the measurement a second time. So you go on the field, you make exactly the same process, and you retrieve the zero profile from your actual measurement, and then you get deformation compared from the zero measurement. So you get a curve that can be like this on the right. So this is the manual. So what's an IPI now? So IPI stands for in-place inclinometer. So this is an inclinometer that you let in place. in for long term. So it's a chain of interconnected probes. So the form of this chain can be diverse. So discretized probe. So you have several individual probes linked with some cables, and you set their position according to a preliminary study, because generally you perform a manual control of your structure or your site, and then you determine position to place these individual probes. Or you can have a continuous inclinometer chain. So the probes are linked together into a chain. So in Sisgeo, we have this chain with variable length and position. The system that's generally removable and reconfigurable. That means that you can perform a monitoring for a time and then retrieve your full system and then reconfigure, shorten or put more probes or change the base lengths of the probes, change the addresses, etc. In our catalog, we are proud to show system where the mechanics has been optimized and the construction of the system makes a difference. So we speak here about the contact point, the ball joint, the spring quality, also the material itself, the rheology of the material, the on weight, etc. So this it's make a difference. And last but not least, we provide each probe with an individual calibration on each axis. So if you have uniaxial, it's calibrated on this axis, biaxial, it's calibrated on both axes, and even triaxial, we calibrate on the full sphere. I will explain it afterwards. So it's calibrated according to the standards. As I said before, we are basing our catalog on the ISO norm. That was for the definition. Now speaking about the system themselves. So the systems are, as I said, hosted by an inclinometer casing. Just small focus on the inclinometer casing. So you can find them in plastic or aluminum. It's much more difficult to find nowadays aluminum because the price of the metal has raised like crazy. So we advise always to put the plastic tubes. In Sisgeo, we provide more of the ABS, acrobutylstyrene. So this casing, as you know, has 4 longitudinal keyways. We call it also grooves. We call them also grooves. So these keyways are diametrically opposed. So you have 2 pairs, orthogonal pairs. The common diameter of this tube that you can find are 48 or 65 or 83 millimeters between the keyways. In Sisgeo, we provide moreover the 65, so the middle one. Let's say the larger diameter can accommodate larger deformation. But if you are using larger tubes, you have also the risk to have a collapse. So the collapse pressure of the tube is lower generally. Also, the contact between the probe and the keyways is less good in the larger tube than in the smaller. So let's say, to sum up, if you have large deformation expected, go over big tubes. If you have very small or no deformation or no space to install your tube, because it can happen, then you can use the small tube. But to have a good compromise, let's go on the middle one that we provide. You have also accessories like top and bottom cans, protective heads in order not to have pollution or stones or other material coming inside the tube. And very important, you have the couplings. So the couplings are here to define the continuity of the keyways. So these keyways have to be completely and strictly continuous in order not to have the system going out the keyways. What's happening if the system is going out from the keyways, then you are not sure anymore about the direction you are measuring. So it's very important to know exactly the direction you are measuring. Therefore, the coupling are very important for that in order to align completely the tube from one to another. So the system of the coupling can be diverse, so like riveted, glued, or you can have O-rings or self-coupled, so different kind of system. So the keyways, as I said, are very important in order to define the axis. So you have two axes. You have the main axis and you have the orthogonal axis. Let's say the minor axis. Although sometimes the minor axis is kind of important. So you have two directions. So a pair of keyways is defining one axis. The rule taken from the norm is to orientate by the installation of the casing one keyway, one pair of keyway towards the expected movement. If you don't know at all how will move your field, which I cannot believe if you design properly your system, but I think if you cannot define it, then you can orientate these grooves toward through the geographic or magnetic north. It's also feasible, but mainly the main direction is preferred for this. In horizontal, you have only one axis. The probe is only uniaxial, and so the principle is to orientate a pair of keyways vertically toward the vertical. So the first system I would like to present to you is our bestseller, is the BH profile. The BH stands for borehole. So this is an in-place inclinometer that comes from the evolution among the years from the manual inclinometer. So you have this probe here with two pairs of wheels that I'm sure you know it. It's made for performing punctual survey at a timestamp, so you have to go every time on the field to perform the measurement. And there you have sometimes somehow reproducibility issues. That means the performance of the systems is bound to the quality of the measurement in practice. So the technician has to perform the measurement exactly in the same way every time. So if you change technician, if you change material, if the conditions on site change, you have always the risk to have a reproducibility issue, and the result will not exactly express what is the real tendency. So this is another topic. Then if you chain this manual probe, then you get this IPI here, standard IPI probes that you can chain also, but you cannot have the information between two probes. That means you have here the inclination information between the two pair of wheels, and for the next probe you have exactly the same way, but between one and the other probe you don't have the information. The optimization was the inclinometer chain here. So we call it BH profile. So the probes are completely interconnected. So electrically and mechanically. That means you have one joint and you have one pair of wheel for two adjacent probes. Also, you have customized unit length. Here, the length is always the same, 1 meter. Here, the base length can be 1 or 2 or 1.5. Even 3, but 3 is not ISO compliant. Or you can make also a mix. You can have different lengths inside the same chain. So the principle is to use a centered and balanced wheel carriage. So exactly like the manual probe, the probe is completely centered into the tube because you have a carriage using a double wheel articulated on spring. So as I said, one common carriage for two probes. The principle is to suspend the full chain from the top, and you have only one bus cable for communicating with the full chain. All the probes and the connectors are watertight IP68 and up to 1 megapascal. That means 100 meter of water column. Then the main advantages of the BH profile in place inclinometer can be listed as follows. You have the lightweight, it's a modular system, it's accurate according to the ISO norm. It has proven efficiency because we have a large experience of this system over the years and on the all over the world. The interface is easy, so you have a I will explain it a bit more afterwards, but you have only one cable and you can interface with a good variety of data logger that are existing on the market. Now a new system has been developed and launched for a few years. So we call it MD Profile. MD stands for multi-direction. So the main principle was to enhance and improve the BH profile and its limitation. As you could see, the BH profile comes from the evolution from the manual inclinometer. Then we had some limitation. We have discovered some limitation. In order to improve them, we have developed this system MD profile. So in collaboration with University Parma in Italy. So the main question was keyways or not keyways. It's a bit Shakespearean, this question, I know, but in a sense, you can avoid to have all the limitation of the wheels, the wheel carriage, with means of a special centralizer. Here, the MD profile, the main difference is that you don't have one pair of points touching the tube. Here you have 4 points, and the 4 points are exactly at the same depth. Here, if you compare the BH profile, you have a spring wheel, and if you compress, if you insert inside the tube, you have maybe up to 10 centimeter difference between the upper wheel and the lower wheel. Here with the MD profile, the thing is completely different. You have only one level of contact between the ground, the tube, and the system. It makes the difference, really. And also, very important, the joint, so the articulation between two probes is exactly at this level here in the MD profile, whereas in the BH profile, the articulation is a bit below here. You cannot see it on the scheme, but it's here. So if you see my face here, just see my face, you can see the size of the two different devices, BH profile, MD profile. It's really not the same system. So trust in Italian mechanical engineering. As I say, you dream to drive a Lamborghini, you let your children go inside roller coaster made in Italy. We in Italy have the mechanical engineering. So we have thought about it in engineering way, how to improve the BH profile. And then we got this MD profile. So the idea here is to use a new centralizer. And this centralizer has a bit small limitation. You have to use a very specific diameter of tube. You cannot use any casing. So the idea the principle is to use a flush casing. So flush means between two adjacent tubes, you cannot have a gap. So no rivets, no gaps, completely flush for all the full length. So we provide special tubes of 2 inches in internal diameter, or you can use our easy lock tubes that have a diameter of 58 millimeters. But pay attention, if you order one or the other, you have a different centralizer. So we have 2 models of centralizer for that. The important thing is, because you will ask, if you don't have keyways, how do you ensure that the position is respected? Then in the engineering, we have developed this joint in order to avoid the twisting between two adjacent elements. That means if the probe at the top is oriented one way, you have a very, very small difference, so neglectable, almost no difference on the lower probe. Let's say this difference is neglectable up to 100 meters. You have an electromechanical connection. So the difference from the BH profile, you have 2 connections. You have mechanical and electrical. Here you have everything in one connection. So you speed up also the installation phase. The base lengths are 0.5. So also the principle of MD profile is that you can also lower the base length up down to 0.5 meters. And again, you have 1 or 1.5 or 2 meter mix is always possible. And the main feature is that the accuracy, thanks to the mechanic, again, because the sensor inside is the same as the BH profile, you have the same accuracy on both axes. So this is really a good improvement and a great improvement from this system. You have the same accuracy and repeatability also. The system is also made almost full of carbon fiber. You have very few stainless steel, and so it's very light and common and useful for the installation. And the system is mainly pushed inside the borehole. So that means you don't have the risk to lose one probe because you don't hold it during the installation. So the property of this centralizer is to be in full contact and under pressure on the edge, the circumference of the tube. So if you insert 1, 2, 3 probes, you will notice it doesn't move anymore. You have to push them inside. The system validation has been made, as I said, by the University Parma. They used a special site, so it was a 7-meter high concrete wall on which they installed 0.5 elements, so 6 pieces, 6 probes, and they had special motors and sensors in order to move the probe individually to 10 micrometer accuracy. So they simulated 2 different situations, A and B, so let's say 1 and 2. The situation 1 is, for example, a continuous deformation like you can have in a diaphragm wall. And the number 2 is a local deformation here, as you could have in a landslide. So these 2 tests has been made, and the cumulative error is very, very small. You can see here the results that are very good. So we have achieved on both axes, axis A and axis B, we have achieved a very, very good repeatability and accuracy of the full string. So the properties, the main advantages are the extra lightweight, whereas the BH was lightweight only. The modularity is conserved. We have 2 times more accuracy from the ISO norm on A and B axis, on both axes, very important. It's very much more cost effective from the BH profile because you have also less stainless steel, and the interface is always remain the same. Last system that I would like to show you is the LT-IncliBus 360. It's a complicated name, I know. So LT stands for local tilt. Let's say LTI. LTI is a small name. I like it. So LTI, what is it? It's a local tilt inclinometer bus, string if you like, with 360-degree calibration. What does it mean? So it's a string of tilt meters that have been calibrated in 3D. So the tilt meters are working and measuring 3D. They are linked together with a cable, and they are supported onto a mechanical rod. So this is a fiberglass rod, and the alignment is ensured with a special coupling here that you interconnect segments of fiberglass between them, and then you have electrical connector that you interconnect also. So you have a full line with aligned and the same orientation of tilt meters, and you can arrange them any way you want because it has the benefit from a new calibration that we have, the 3D 360 calibration. So you can measure in any way you want. You can put it into a circle. You can make vertically, horizontally, as you wish. The system is completely watertight to 1 MPa, and on request we can test to 2 MPa, 200 meter of water column. So the principle is to use 2-meter segments. So the segment is not you cannot modify it. So it's 2-meter base, and on this 2-meter you have whether you can have 0 tilt meter, so just an extension rod, or 1 tilt meter in the middle, or 2 like in the picture, or 4, each 0.5 meter. So in this way you can also mix and make different systems. The principle, so the system obviously is very light, is modular. It can be embedded. So that means the system, in essence, should be lost. It's not retrievable like the other probe that I showed you before. Here, the system is intended to be embedded, so lost in concrete, lost into embankment, water, etc. So it's now a 3D. So you have the ISO accuracy needed on the full sphere. It's cost effective, so much more than the other system because you have less material, and the interface remains also always the same. So I have presented you these systems. Now I would like to ask you to reply to a small poll. Here, the question is, which kind of IPI have you already used in your experience? You have multiple choices possible. You can see, so I don't use IPI, or I use single probes or IPI chains, or IPI chains without the wheels, so MD profiles, or IPI chain not from Sisgeo. I let you some seconds to fill in the form and to reply, and then I will share with you the results. So you are 100 people almost, so I will wait 30 seconds, let's say. Be serious, huh? I control the result after. Okay, so the results are stable more or less now. 2, 3. Yeah, we are almost at the amount of participants. Okay, so I'm going to end and share the result now. So the majority of people don't use IPI, or if they use them, it's shared between single probes and the classical IPI. So a few people use the brand new systems without the wheels. So I think this webinar has a good goal here to show you what is possible and why is it possible. What do you use? Would you use an IPI? So I close the poll and I go back to my presentation. So we are proud, and for us it's very important to show you that our systems are compliant with the ISO norm. So this ISO describes the state of the art for all borehole inclinometers. So that means the norm doesn't make a difference between manual system and automatic system. So the parameters that are mandatory from the ISO norm are exactly the same from the manual to the automatic. So we are proud to provide systems that are completely compliant in automatic or manual mode. So here you can see the ISO, the first column is the values or the data that the ISO norm requests on each data sheet of the provider. So if you want to purchase a device that is ISO compliant, please pay attention to these values that are mandatory. So we are, of course, providing all these values in our data sheets, and all these values, as you can see, are compliant. Just here notice that the repeatability over 30 meter for us is the most important because accuracy of the probe is important. But as I said, mechanics, the way you install the casing, it's much more important because the final result depends not on the system accuracy, but on the full chain accuracy, the repeatability and the stability. So here, as you can see, the norm has plus minus 2 millimeters for 30 meters of system, so manual system or automatic system. Here, the BH is compliant to exactly to this value, but the MD is 2 times more accurate, more repeatable, let's say. So this is a value that you have to pay attention when you purchase your system. To date, Sisgeo is the only manufacturer to comply with all its Inclinometers IPIs. I have verified. Sensor technology. So, as I said, we provide individual calibration for each probe or tiltmeter that is coming out from the factory. So we use accredited test benches. We compare directly with the references, so the official references, so an accreditation office come to us in order to validate the system. So we define some steps, we obtain a table, and from this table we interpolate in linear and polynomial, and we calculate the error from the theory to the sensor. The sensor is compliant if the error that we get is lower than what we state in the datasheet. So that means when you purchase a system from us, it's at least better than what we are stating in the datasheet. It's always better than that. So it cannot be worse. If it's worse, we just throw the sensor away. Just few words about the new calibration. So we are using new accredited test benches, and we are using now this calibration for tiltmeters. So the LT-IncliBus is also benefiting from this new calibration. It's compliant to the ISO norm of the complete sphere. So that means you can orient it however you want. You will always have the good accuracy, and this is due to two things. Because we don't use any algorithm, we don't use magic, we give true data because the sensor is calibrated on benches on the complete sphere. And this is why we are compliant. And also we have a feature inside. The output in digital is optimized between the three axes, X, Y, and Z. That means if one of the three axes is out from the range, is deactivated. So you get only data from sensors that are in their better position. So it's a feature that we provide in this calibration and it's in these tiltmeters. Few words about the data output. We use RS485 digital output, Modbus RTU. So the protocol is available on our website. So we use unique address probe. So each probe has an individual address and it's connected to a single master unit. That means a data logger. We can use 247 maximum probes in a string. For the probes, we use the standard calibration in sine of angle that you can convert into millimeter per meter, as I explained. Or you have the 360-degree calibration, and then the angles are expressed in degrees, directly in degrees. So each probe returns angles, temperature, and also internal power and humidity. About the data loggers, few words. You can use wired, so completely wired data loggers like OmniaLog or other loggers from the market, or wireless loggers like we have here, the WearLog. The best is to connect with the platform in order to display, interpret directly the measurements, and create some alerts. The data display has to comply with the ISO norm, so you have to show the cumulative displacement for each axis, A and B. You have to compare with the zero reading to have the displacement, not only the profile, and you can also display the vectors. So this is the combination between A and B axis. So you make a Pythagore formula in order to get the resultant, and then you get also the azimuth in order to display where is the resultant, the main deformation in a polar convention. So that was about the systems. Now finishing with the application. I will show you some applications for these systems. So at first, the advantages of IPIs. So what does bring IPI? IPI is used in order to enhance the monitoring on critical location. So you can understand easily that the manual system is cheaper because you invest one time, but you have to repeat the measurements and then you have to repeat them accurately in order to have no repeatability issues, but you still have risk of repeatability issues. Therefore, if you need more data or no repeatability issues, please use IPIs because IPIs are installed once and they monitor at this point, at this level, at this depth, continuously the deformation. So we have a dense data set coming out from the system. So this dense data set allows to have early warning because you can imagine if you have one measurement every week, then you have less reactivity than if you have 3 or 4 or 1,000 measurements in a day. I don't recommend 1,000, by the way, because you have to interpret the data. It's also work, but this is the principle. So it's better combined with a data logger, of course. You can also use a manual device, as I'm showing on my camera. This is a mind device, so you can read the digital chain with that. But you have to go on site and measure. So it's not really designed for that. It's much more designed for a data logger. And the data logger has to push the data on a web-based platform in order to make the calculation online and the alerting. So where can an IPI be used? So I don't explain the full list, but you can see there are many applications possible and sectors possible for that. Mainly, let's say, landslides and excavations. Oh, this is walls and slabs also, but let's say landslide and excavation are the two main sectors where you can encounter these IPIs. But all the other applications are also important. But let's say commonly we encounter them many times in these two situations. I don't explain all the applications. I don't have the time, and maybe you don't have the patience to follow everything, but I will focus onto three main applications. So the first one is the most common one, I think, the deep excavation process. So you have here a trench or a deep excavation that is being performed. So the principle is to follow the deformation of this wall here. So you can create a borehole and install the chain very close to the wall, or directly install inside the support, inside the wall. So for that, you need a special technique. You need to pre-install steel tube in which you are installing your chain, because the chain and the casing are very sensitive. You cannot install it and then create your diaphragm mold. Is too delicate, let's say. Typically, in this kind of situation, we expect very low displacement. So the alarm level is very small. So I would advise to use the highest accuracy system. So for example, here, MD Profile. Really, I advise this kind of system. If you have a pre-installed casing that are not compatible with MD Profile, you still can use the BH Profile because the BH Profile is adaptable to almost all tubes on the market. I think all tubes on the market. Also, the alternative could be to use LT-IncliBus chain. So therefore, you can prepare on the reinforcement cages the LT-IncliBus chain and then to let it go down with the reinforced cage, and you will have your tiltmeters directly embedded into the system. So the disadvantage of that is that your system is not retrievable anymore. So you install and then it's lost forever. But you have a very clever and quick way to equip the system, because you can imagine The other two, you have to pre-install something and then to install the casing and then to install the probe. So it's three operations. These are three operations. Here you have only one operation, and it's also cheaper. So one example here that I like to present is the one in Paris. So in Paris, as you may know, that was the Olympics this year, and the plan was to have a complete new metro system. So it's still in construction, the metro system, and for this metro system, there were a lot of TBM running, so up to 21 TBMs at the same time, and all these TBMs has been mounted into big trenches, big excavations like that. And for each excavation, we had thousands, I insist, thousands of this probe, this pH profile probe. So it worked very, very, very well. Other application that we can present is the landslide. So the landslide, so as you know, is a mechanism that is linked to two things: the geology. So there is a difference between a soft and hard layer, and you have also the influence of water, so rainfall or weather conditions. So the idea here is to continuously monitor some parameters like water level, temperature, weather conditions, pore pressure. But the most important, in my opinion, is the horizontal displacement, because you are really monitoring the kinetic of your movement. So the horizontal displacement can be measured, of course, with a manual inclinometer, but when the landslide is really moving and really sliding, and you have danger for structures or communications ways, then it's advisable to use IPIs in this way. For example, here, an example in Germany. So this is a slope monitoring during a deep compaction. So you have here an embankment, and this embankment has been completely over compacted in order to achieve a good stability of the ground. So we used many MD profiles here to monitor the effect of this compaction onto the embankment edges. Also, another example that I performed myself. Here you can see my face, maybe. That was 2 weeks ago in Belgium. I installed with a client on a landslide some MD profile probe, so you can attest here. It's quite easy to do, and let's say here that was 2 meters, that were 2-meter elements down to 30 and to 40 meters, and the installation of one string was 10 minutes, not more than that. Last application that I would like to present, and then we can run on to the Q&A. This is the monitoring of a tunnel that exists. So if you would like to monitor the settlement during underground excavation or neighbor excavation coming, then you can use a string of tiltmeter or MD profiles fixed on the roof or on the sides of the existing tunnel, and you will have the possibility to follow the relative movement between the tunnel elements. So it's a monitoring of vertical displacement, and the advantage of this system, it runs underwater. So if you have a system that is completely full of water, then this string will be completely watertight and will run also underwater. Here an example in France, again in Paris. So you have a water tunnel, and inside this water tunnel, a string of IPI has been installed on the roof in order to follow the relative movement. Here you can maybe guess the joint between two elements. So the IPI is here to monitor the moving of the two elements relatively from one to another. That was it. I hope you enjoyed. Now we open the session of question and answers. Giovanni should appear again.
Yes, I'm here, Julien.
Good. So just a small reminder, you can have plenty of information on our website. So you have a lot of manuals, frequently asked questions where we already gave answers. You have also a lot of replies in data sheets. You have also videos, applications, etc. Don't hesitate to go there. Don't hesitate. We are available, but also you have a lot of replies into that. So the first question, Giovanni, would be, can we install an MD profile into an existing standard 70 millimeter inclinometer casing? If yes, what are the risks of something going wrong?
Actually, we don't have the centering device for the 70 millimeter internal diameter. So in this casing, we can install BH profiles or a string of LT-IncliBus. We don't have actually the centralizing for the 70 millimeter diameter.
Okay. So how do you initialize and calibrate the in-place inclinometer?
So the question, if I correctly understand, is how to take the reference readings
Yes.
to start. Okay.
So
So
it's described in the
would you like to?
ISO, huh?
Yes, yes. But anyway, my strong suggestion. I'm the person that I'm answering for Sisgeo to this question every day. One of the most important things is to test the probe. I know it's a stupid suggestion, but please follow it. Test the probe before the installation, during the installation, and after the installation, in order to know that your probe that you are going to install are perfectly working, 100%. So then we suggest to wait 24 to 48 hours after the installation to have all the system well stabilized, and then take these readings as a reference readings
Okay.
for the
I have a
interchange.
question here. I think I will reply. We are looking at monitoring slope stability for a tailing dam. The embankment is about 1 kilometer long. So, if we use multiple LT-IncliBus, which is better way of deployment for a trench deployment? For example, long question, huh? Individual inclinometer spaced across the 1 kilometer, but not continuously, or continuous with some of them only continuously with 0 inclinometer, or combination. So LT-IncliBus allows to make different combination. The only limitation is the let's say the authorized length of the digital string. So you cannot have 1 kilometer of inclinometer string, digital string, with a small cable. You have to use a greater section. So there are some combinations that are possible. We have studied some examples in the Middle East lately. So please contact us again through email, and it will be a pleasure to reply to you. But things are possible, yes, for sure. I don't know. A lot of thanks for the webinar. You mentioned the terms accuracy and repeatability together. Which one is related to your products? All, I would say.
May I answer, Julien?
Yes, please.
Yes. So following the ISO standard 18674-3, the standards literally say precision and between the parentheses repeatability. So don't speak about the accuracy of the system, but the precision in terms of repeatability of the system. So what Julien push along the webinar is the plus or minus 2 millimeter above the entire chain of 30 meter. So the most important things to take in account is it's okay. The target of having a good and well accurate instrument. But keep in mind that the most important data is the precision and repeatability of the system. So, for example, for a string of 30 meter of IPI, to stay in the repeatability of plus or minus 2 millimeter for the entire chain, so the cumulate data interpretation. If you would like to add something, Julien.
It's enough clear for me. I would not say more than that. Another question, much more for the tubes. Did you already face bad installation of the tube from the drilling companies? So we as Sisgeo know because we are providers, or maybe our clients have experienced that. But the question remains: do you usually pay attention to reference inclination of the tube? If it is not completely vertical, will it affect the measurement, and how?
So again, the ISO standard says that the drilling and so also the casing must be installed with a total inclination along the whole length of plus or minus 2 degrees. I know that it's a strange request, let's say, because if I have 10-meter drilling, I can control the deviation between plus or minus 2 degrees. But if I have 100-meter drilling, is very difficult. The request of the standards is, in my point of view, in order to use the sensors and the probes more vertically as possible, because it's a long answer. I try to shorten it a little bit. We calibrate our sensors and we give the MPE, the maximum permitted error, as in the datasheet. And the maximum permitted error that we calculate in the calibration is between the entire full range of the sensor. So, and actually the maximum error is not in vertical position, but near the full scale position. So the ISO standard is just requesting to keep the probe and to use the probe more vertical as possible in order to use the probe in the more accurate position as possible. I hope that this is clear enough.
We have some minutes left. I take a last question. How do I ensure that the measuring chain consisting of MD profile probes does not twist inside the tube in a measuring tube without the guide grooves? It's during the installation, I think, the question. Huh? So you have this insurance that one probe is not twisting from another. This is one point. The second point, you have also a special tool provided with the system that ensures you that the system is not twisting during the push. So these are two features that we are providing for that. Right, Giovanni?
Yes, right. You're completely right.
Okay. We cannot answer more questions, but I see there are 2, 3, 4 that I didn't read. So the principle is we will reply to each of you with the written form. Don't leave now, because I have to announce that we are organizing soon a masterclass for inclinometers. So all you saw here raise a lot of questions, and you have a lot of practical questions about drilling, about the design of the systems, about the readings themselves, the errors that you are generating, and all the replies. Almost all the replies will be contained in this masterclass. So this masterclass is not free, so you have to pay to access it. So I will be the professor for that. And the principle is to have 3 modules of 1 hour each. So more information coming in the beginning of next year. You will have the opportunity to reach the platform. I think before the spring, or just at the beginning of the spring next year. Let's see. So stay tuned on the social networks. We will give you some information for that. So I hope you enjoyed the session. Thank you, Giovanni, for your availability.
Thank you to you, Julien. You're a great professor.
Yeah, thank you. For people that are in Australia, good night. For people that are in America, have a good coffee. And for Europe, Have a nice afternoon and a great weekend in advance. See you.
Thank you. Thank you, everybody. Bye-bye. See you next time.